If you like this video, please subscribe. Thank you. The first effect of insulin binding to the insulin receptor is to activate the tyrosine kinase activity of the receptor, which then autophosphorylates itself on specific tyrosine residues, and the activated tyrosine kinase receptor will then phosphorylate specific intracellular proteins, including enzymes and adapters on specific tyrosine residues. The activation of the tyrosine kinase activity of the receptor by insulin initiates a plethora of intracellular effects. One of the effects that insulin initiates in the cell downstream from the tyrosine kinase activity of the receptor is the activation of a phosphoprotein phosphatase. This phosphoprotein phosphatase will proceed to dephosphorylate some key enzymes in metabolic pathways, altering their activity. And as such, insulin will have remarkable effects on both carbohydrate metabolism and lipid metabolism. Although insulin initially activates the tyrosine kinase activity of its receptor, the downstream effect of insulin is to dephosphorylate specific target enzymes, changing their activity as a consequence. There are at least 5 enzymes that get dephosphorylated by the actions of insulin through the action of phosphoprotein phosphatase. And these are: 1. Glycogen synthetase. Glycogen synthase gets dephosphorylated by the actions of insulin on its receptor, and thus activating or stimulating the activation of this enzyme and stimulating glycogen synthesis. 2. Insulin dephosphorylates fructokinase 2, PFK2. This enzyme is responsible for the production of fructose 2,6-bisphosphate, a very potent allosteric activator of PFK1 in glycolysis. So the production of more fructose 2,6-bisphosphate will activate PFK1 and therefore activate glycolysis. 3. Insulin will stimulate the dephosphorylation of pyruvate kinase, the last step in glycolysis. The dephosphorylated pyruvate kinase will then be activated and therefore will activate glycolysis overall. 4. Insulin will dephosphorylate HMG-CoA reductase, the rate-limiting enzyme of cholesterol biosynthesis. In the dephosphorylated form, HMG-CoA reductase is more active and therefore the result of its dephosphorylation is to increase cholesterol biosynthesis in the liver. 5. Insulin will dephosphorylate the rate-limiting enzyme of fatty acid synthesis, acetyl-CoA carboxylase. The outcome of dephosphorylating that enzyme is to activate it and therefore increase fatty acid synthesis in the liver as well. There are at least 3 enzymes that get dephosphorylated and inhibited as a result of insulin activating its receptor. These 3 enzymes are 1. FBP2 or fructose bisphosphatase 2, which is the enzyme responsible for breaking down fructose 2,6 bisphosphate. In the dephosphostate, FBP2 becomes inactive and is unable to hydrolyze fructose 2,6 bisphosphate, thus allowing glycolysis to proceed. 2. Glycogen phosphorylase. This enzyme gets dephosphorylated by the effect of insulin through its receptor. In the dephosphorylated form, glycogen phosphorylase is inactive and therefore it is unable to hydrolyze glycogen, decreasing glycogenolysis. 3. Insulin will promote the dephosphorylation of hormone-sensitive lipase in adipose tissue. As a result, the enzyme becomes less active and therefore will not be able to hydrolyze stored triacylglycerol in adipose tissue. In summary, it is noteworthy that insulin will stimulate through a cascade of events initiated by receptor activation a downstream effect on phosphoprotein phosphatase, which will then dephosphorylate specific and key enzymes in various metabolic pathways. As a general rule of thumb, insulin will always promote dephosphorylation of some of the enzymes mentioned before. In some cases, insulin dephosphorylation of key enzymes will activate them, and in other cases, insulin dephosphorylation of these other key enzymes will inhibit them. It is also noteworthy that the phosphoprotein phosphatase activated by the insulin receptor downstream from the receptor specifically hydrolyzes phosphoserine and phosphothreonine residues on all the enzymes that were mentioned before. If you like this video, please subscribe. Thank you.